Lesson 8 is solving exponential equations with technology. So 8.1, we're going to be solving exponential equations that have exponents that are monomials, meaning one term. So before we get started with the actual examples, there's a couple of formulas that come in handy for this lesson. The first one is the change of base formula. So the change of base formula says if you have log base b of x, you can rewrite it really using any base, but we choose common log or natural log. You can rewrite it as log of x over log of b, or natural log of x over natural log of b. So it's just important to know that what we were originally taking the log of goes in the numerator, and the original base goes in the denominator, and it'll always follow that same pattern. The other thing that's helpful to review is how to change between log form and exponential form. So let's say I have b raised to the x power equals y, and I want to rewrite that in log form. The base of the exponential is going to match the base of the log, so it'd be log base b, and then exponential form to log form, the exponent from exponential is going to be isolated in log form. So that means that the x, because that was the exponent, is going to be by itself once we convert it to log form. And then the last thing we need to place is just what we're taking the log of, which was y. So one more time, the base of the exponential will match the base of the log. The exponent from the exponential is what ends up by itself or isolated in log form. And then what the exponential is originally equal to ends up being the argument of the log. That one we don't have a great name for, base, or talking about isolating the exponent. So it's usually the thing I place last. Okay, so you'll see throughout this lesson we talk about method number 1 and method number 2. It really doesn't matter which one you pick as your favorite or your preference. In fact, you can always choose one over the other. There's not going to be certain problems where you have to use method 1 or method 2. I just wanted to introduce both to you so that you can decide what is best. So method number 1 is going to be taking your equation and rewriting it in log form. So first problem is 2 raised to the 3x equals 19. If I want to rewrite this in log form in order to solve, I first have to figure out what my base is. The base is 2. So I'm going to rewrite it in a log form with that same base. So it'd be log base 2. And then I know that the exponent part is going to end up on the other side of the equal sign by itself. So I'm going to say equals 3x. And then that 19 is now what we're taking the log of. So equals 19. And then that's just using this pattern up here, to convert between the two. So that's something that if you're not super comfortable with yet, it's totally okay. But I would always have that on a little sticky note or at the top of your page until you get comfortable with it. So log base 2 of 19 equals 3x. And then now I can start working towards getting the x by itself. Before I actually cancel out that 3, I want to get a number for that log base 2 of 19, and in order for me to get approximation for it, I have to change its form using the change of base formula. So if I use the change of base formula, it's going to change into a fraction, and the what we're originally taking the log of will go in the numerator, and the original base will go in the denominator. And you can change it using common log or natural log. I'm going to use common log. So it'll be log of 19 over log of 2 equals 3x. And then now this is something that I can put in the calculator and get a decimal approximation for. So we'll do log of 19, and then if I want to do it all in one step, I need to close the parentheses. So log of 19, and then close parentheses, and then divided by log of 2. And you can see it's about 4.2479 and so on, but I'm going to round this to 3 decimal places. So it'd be about 4.248 because that 9 would round the 7 up to an 8. And then is equal to 3x. And then my ultimate goal in solving is to get x by itself. So I have to cancel out that 3. So that 3 is being multiplied by the x. To cancel it out, I'll divide both sides by 3. And if you want, you could just leave that 4.2479 and so on in the calculator, and then just click divide and divide it by 3, and it's going to end up being a more accurate answer than if I rewrote 4.248, because that's a rounded version. So I'm just going to leave it as is and then divide it by 3, and then you see it's about 1.416 if we round to 3 decimal places. So we'll say x is approximately 1.416 because that 9 in the 4th decimal place would round that 5 up to a 6. So x is approximately 1.416. Okay, so that was method number 1, that's rewriting in log form. The second problem is going to be method number 2, which is logging both sides of the equation. So for this one, we're going to solve x raised to the, 12 raised to the x over 2 equals 42. So I do this problem a little bit differently than like the workbook does. So if you want to see a different version or a different like method of using the same problem, even though it's logging both sides, you can read through the workbook. It looks a little bit different, but it ends up in the same place. So in order to like solve for x, I have to get rid of that 12, like have to free up that exponent. And that 12 is an exponential, so I have to use the inverse of an exponential. I would have to log both sides. So in order to do that, I have to figure out what my base is. The base is 12, so I'm going to log base 12 both sides of the equation. So log base 12, 12 raised to the x over 2. And then over here, I have to do it to the other side as well, so log base 12 of 42. So both sides of the original equation get log base 12 as their like operation. And then we have a log with a base of 12 and an exponential with a base of 12. Those are inverse operations and they cancel each other out, and they would free up just the exponent part. So just the x over 2. And then over here, this log base 12 of 42, I eventually want to be able to get like that into the calculator, figure out what my decimal approximation is if I'm trying to solve for x. So I have to rewrite that using a change of base formula as well. So what I'm taking the log of goes in the numerator, the original base goes in the denominator, and you can use common log or natural log again. It doesn't really matter, it'll end up getting the same answer at the end. So log of 42 over log of 12. And then I can go ahead and put this in the calculator as is. So we'll do log of 42. And then don't forget to close the parentheses if you're going to do it all in one step. And then divided by log of 12. So it ends up being about 1.504. We round to 3 decimal places, and then I still have to bring down this x over 2. And then remember, with solving, your ultimate goal is to get x by itself, so I have to clear that 2. That 2 is like being divided, so it's like x divided by 2. So to cancel out that division, I would multiply both sides by 2. So the like multiplying by 2 and dividing by 2, that cancels out. And then now same thing here, I'm just going to leave that big long decimal in the calculator and just go ahead and multiply by 2 as is, because my answer will be more accurate that way. So 1.504 ... times 2 is about 3.008. So we'll say x is approximately 3.008. Okay, so looking at those two problems as a whole, like I said, method 1, you were rewriting in log form to like get x by itself eventually, and then method 2, you were logging both sides. We could have done either problem with either method and gotten to the correct answer, so it really just comes down to personal preference. Okay, so 8.2 is going to be kind of the same setup, it's just our exponents are going to have multiple terms in them. So we'll do the same thing, method number 1 of rewriting in log form. So we're going to solve 2 raised to the 4x plus 3 equals 17. So if I want to rewrite this in log form, I have to figure out what my base is first. My base is going to be 2. So log base 2. And then my exponent is going to end up by itself. So equals 4x plus 3. And then what I'm taking the log of, that's the last thing in place, it's going to be that 17. So I would recommend, until you get super comfortable, following like the same order. So like the base of the exponential will match the base of the log. The like exponent part from the exponential will be isolated when it's in log form. And then what we're taking the log of is the last thing in the place. It's called argument, but that term isn't used all the time necessarily. So sometimes it's just easier to say what you're taking the log of. Okay, so now, yes, eventually we're going to try to get x by itself, but I really want to get some sort of like value for this so that I can start to work towards like the other side, getting the other side of the equal sign simplified. So log base 2 of 17, same thing, like I can't plug in a log with a base of 2 into a regular calculator, so I have to use a change of base formula to rewrite it. So what we're taking the log of goes in the numerator, the original base goes in the denominator. So log of 17, and same thing, you could use common log or natural log, doesn't matter. And then log of 2 in the denominator. And then equals, we'll have the 4x plus 3 over here, just bring that down as is. And then this now I can put in the calculator as log of 17 divided by log of 2. So we'll do log of 17 and then close parentheses and then divided by log of 2. So it's about 4.087. So 4.087 equals 4x plus 3. And then my ultimate goal is to get like x by itself. At this point, I just have like a two-step equation where I have a couple things I have to cancel out. For this one, I am not just gonna leave it in the calculator since I have more than one step, but you could if you wanted to. I just feel like it might be kind of hard to follow. So I have to get x by itself. There's two things being done to it. There's the 4 that's being multiplied and the 3 that's being added. Usually we undo addition or subtraction first. So I'm gonna cancel out that adding 3 by subtracting 3 from both sides. So 4.087 minus 3 is 1.087, and then equals 4x. And then now I just got to cancel out that 4. That 4 is being multiplied, so I'm going to divide both sides by 4. And then here's where if you wanted to leave it all in, you could just do like minus 3 to get that like 1.087. Either way, you should end up with something that's like close enough to like the exact answer, and it's like okay to round that much. So it'd be 1.087 divided by 4. A is about 2.7186 and so on. I'm gonna round to 3 decimal places though, so that like 8 will round the 1 up to a 2. So we'll say x is approximately 0.272. Okay, so last problem, this is using method 2 again, where we log both sides of the equation. So for this one, we're solving 13 raised to the x over 5 minus 1 equals 28. So if we're going to log both sides of the equation, we have to figure out what type of log would cancel out this exponential, because my ultimate goal is to free up that exponent so I can start to solve for x. So the base of the log is going to match the base of the exponential, which in this case is 13. So I'm going to log base 13, both sides of the equation. So we'll do log base 13 of 13 raised to the x over 5 minus 1, and then equals, I have to do the log base 13 on the other side as well, so log base 13 of 28. And then the log with the base of 13 and the exponential with the base of 13 will cancel each other out because those are inverses, and they will free up just the exponent part. So it'll leave me with just x over 5 minus 1 equals, and then now this log base 13 of 28, that's something that I'll eventually be able to put in a calculator. I just have to rework it using the change of base formula. So we'll set up our fraction, and then what we're taking the log of goes in the numerator and the original base goes in the denominator. So it'd be log of 28 over log of 13. And then now this is something that I can put directly in the calculator. So we'll do log of 28. And then if we want to do it all in one step, we have to close the parentheses, divided by log of 13. So log of 28 divided by log of 13 is about 1.299. So 1.299 if we round to 3 decimal places. And then I'll bring down the x over 5 minus 1. And when we're solving, our eventual goal or ultimate goal is to get x by itself. So I have to start canceling out the things that are being done to it now. So the x is being divided by 5 and there's a 1 being subtracted from it. Usually we undo addition or subtraction first. So to cancel out that minus 1, I would add 1, and then I have to add it to the other side as well. So I would bring down the x over 5, and then the minus 1 and the plus 1 would cancel out. And then I would need to add 1 to the 1.299 to get 2.299. And then same thing, goal is to get x by itself. Now I can go ahead and clear that 5. So x is being divided by 5. So to get rid of that, I would multiply both sides by 5. So multiplying by 5 and dividing by 5, those would cancel. And it would leave me with just x. And then now I can go ahead and multiply the 2.299 times 5. I can also just kind of keep it in the calculator if you prefer that. It'll end up being a more accurate answer. So right now in the calculator, we just have the 1.299. And so first we'd have to add 1. I didn't do that step yet. So we do plus 1. And then click equals. That'll give me the 2.99. And then that 2.299 is what I'm multiplying by 5. So times 5 to get my final answer, about 11.496, because that 6 that's in the fourth spot would round the 5 up to a 6. So I say x is approximately 11.496. And then if you ever notice that like you have pretty much the correct answer, but it's getting like marked wrong off a rounding error or something like that, just shoot me a message so that I can like fix it for you. Okay, so looking at the notes as a whole, like I said, there's 2 methods for solving these problems. You can like rewrite in log form, that's method number 1, and then method number 2 was to like log both sides of the equation. Really doesn't matter which method you pick pick whichever one you prefer, and there won't be certain problems that have to be done a certain way. So it really just comes down to personal preference.